Hey folks, so in this video we're going to start introducing linked lists. And the way we're going to introduce it is by talking about our motivations. In the last video we saw that our performance analysis for isEmpty as well as for pop were pretty good. Both of them were linear time, and simply put, you're not going to get any better than linear time. The one that gave us a little bit of trouble though is push. The problem with push is that resize ability, right? So we already had added the fix basically to deal with the fact that if we push to an array that's already full, we're going to throw an exception, right? And our fix for that was let's build the bigger array. Well, build a bigger array implies we need to basically take every element from one array and move it to the other. That looks like an O of n operation to move all those n elements, right? So how can we deal with that? And we're going to try to deal with it the best way possible. Now, for some people, they'd actually be kind of okay with it because there's this idea that most of the time you use it, it's going to be O of 1, right? So if I use it, 50 times, 49 times, it will be O of 1, and it's only the 50th time, there'll be O of n, right? You'll pay the cost to resize, right? And so this is okay. It's maybe appropriate to say that function is big O of n because big O represents an upper bound or a worst case. But usually we don't care about, well, the worst case is important to know, but also what we care about is the average case. Like, what is the average case, right? So the average case is O of 1, so that maybe it fares well, but then you still have to pay that high cost at some other point. So sometimes what people will say is they'll say push is O of 1 amortized. So what they're saying there is you're going to call that you're going to have to resize it so infrequently that you can basically average it in, right? So rather than it being a true O of 1 function, it's O of 1 just because on average it'll be O of 1, okay? And you can say that, but the problem is it's correct, but it kind of hides the fact that it's still O of 1 in certain cases, right? So if something goes wrong, right, if you all of a sudden have to do a resize at a particular moment, you're going to pay O of n cost. What happens if that's the time you need to push and you need to do it efficiently, right? That would be a bad thing. Really, it would be better to have our push function be O of 1 for all cases rather than just most, right? So that would be a better approach. Now, our general problem having to resize, right, really just applies to push right now. It would apply to pop as well if we maybe wanted to worry about reducing the size, right? So if we care about memory consumption, right, we'd have to then worry about that. And so ideally, right, what we want to have both push and pop implemented in O of 1 time. And what would be even cooler is if we have them implemented in O of 1 time and also actually make the amount of memory reserved exactly what we need, right? So instead of having to waste space, right, having to over allocate or something like that, right, rather than having to do that, it would be nice if the space was exactly the same. So let's try and do that, right? Let's try and make push and pop both be big O of 1. Let's try to make the memory usage map exactly what we need. Now, in order to do this, we're going to introduce a new type of basic data structure. So moving forward, we're going to start working with the concept of linked lists.